Hello, Maurits here, and welcome to this video on how to calculate the binomial distribution values on your calculator. So in the last video we talked about the problem with this die thing, and we said that the probability for success was 1/3 and the number of trials was 5. And this, by the way, is often written that our random variable x is a binomial distribution. This sign here means that it's of that type. So the x is of the type binomial distribution, and then we write the number of trials, comma, the probability. So in general, a binomial distribution, a short way to say that something is a binomial distribution is to say that it is the form, so x is of the form binomial distribution with the number of tries you write first there, and then the probability for success you write there. So this is a particular case of that. So if you see that someone says, okay, this is a random variable of that particular case type, then we know that the first number is the number of trials and the next number is the probability. And say for the one we have here, in the last one we found a particular probability for this, right? The probability that capital X equals to 2. So in other words, the number of successes is 2. And we did calculate that by hand, but we can also calculate that on calculator. So we go to stat mode. And here we have the choice distributions. If you don't see that choice, it looks like this. You can go with F6 to get further choices. Choose distribution, and then we have the binomial distribution there. This first thing here is that the binomial probability distribution. The second one is for the cumulative distribution. We'll look at that in a moment. We'll choose the first one, and I will say that change this to var. It says like this. X here, that is the x over here, right? So we write 2. Number of trials, oh, that was the number here, right? 5. The probability, that is this here, right? So 1/3. X, and then I can press X again, and I get the same result as we got last time, 32.9%. Yay, it works. And of course, we can just then choose X again, and then we can enter other things here. So for example, what is the probability that, what can we say, with 4 successes? X again, and okay, that would be 4%, something like that. So suppose we have this question instead. What is the probability that the number of successes is less than or equal to 2? In other words, that we could calculate that as probability to get 0 successes plus the probability to get 1 success plus the probability to get 2 successes. That would be a bit of work, right? So happily enough, this can be fixed because we have a cumulative distribution calculation here, and that calculates all the values up to the given value. So the probabilities for 0, 1, and 2. So we go here to distribution again, binomial, and choose the second one here. You will have a third one there also, but we don't care about this here. So we would pick this one here. See through this, it says variable. We have the same thing, and I change this to 2 and x again, and we find that this probability equals to 79.0%. If we would be asked what is the probability that x is larger than 2, then we simply take 1 minus the probability that x was less than or equal to 2, right? Because these two must be component. Either we have more than 2 or less than or equal to 2. So we can calculate that 1 minus this value. So that will give us 21.0%. Hope this helped a bit. Thank you.